Let's take a look at how to write the equation of an ellipse. So there's two examples in this video, example 2A and B from your notes, one where the ellipse is centered at the origin and the next one where the ellipse is shifted. So in order to write the equation of an ellipse, you need the A value, the B value, and the center. So the first thing you'll try to find is the center. You will do that by looking at your graph and just counting. So you can see that we've got points up here and down here. So how many spaces are between them? You can just count. 1, 2, 3, 4, 5, 6, 7, 8. So that's my major axis. I can tell that's my major axis just by looking at it. If I wanted to go ahead and count here, 1, 2, 3, 4, 5, 6, I could see that that's a smaller number. Your major axis is always your larger number. So some information that I know right now is that the length of my major axis is 8. And we just counted, and our minor axis was 6. Well, some information that's important is that your major axis always goes along with A. You know that by now. Now this major axis is in line with Y, so that means that my A value is going to be paired up with Y, which would mean my B value is paired up with X. Now what are those A and B values? The A and B values go from the center. So here's my center. We can see now that the center is at the origin. And the reason why, because that major axis is 8, which means 1, 2, 3, 4. Right there is going to bring me to the origin. My minor axis being 6 means that half, 1, 2, 3, would bring me to the origin again. So that's the center. We can jot that down, I guess. Center is 0, 0. If my major axis was 8 units, that is not my A value. That is not A. The way you find A is by chopping it in half. So A is actually going to equal half of 8, which is 4. And we got the 8 from counting. You could also count from the center. Sometimes it's helpful when it's shifted, though, if you can just find the major axis and cut it in half. So my A value is 4. My B value would then be half of 6, which is 3. So now we can go ahead and write our equation. We have everything that we need. The equation of our ellipse is going to be x minus h squared plus y minus k squared equals 1. Now we have, in this case, our a squared is underneath our y because we already decided that a went with y, that our major axis was parallel to the y-axis, which would mean that b squared would go under the x. So now we have all that information. We can just plug in all the good stuff. So we can plug in x minus 0 for my center's x-coordinate plus y minus 0 again for my center's y-coordinate. And then we've got our b value, which is 3, and we'll square that. And we've got our a value, which is 4, and we'll want to square that. So you're going to want to clean that up a little bit. I'm going to erase, make some more room for myself, and just write it nice, make sure everything is simplified. So x minus 0, we'll just leave that as x squared. 3 squared will become 9, plus y minus 0, we'll leave that as y squared. 4 squared will become 16, equals 1. There is our equation. So now we're looking at example B. First thing we need to figure out is where the center is of our ellipse. So we want to be really careful. We're going to count. We're going to find those vertices. So I can see I've got a vertex here and there, and I know that's my major axis because I can see it's a little bit larger. And then I've got co-vertices up here and down there. So I'm going to go ahead and count to find the length of my major axis. So my major axis is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So my major axis is 14, which that's telling me that A equals 7. Remember, your major axis always goes with A, and your A value is half the length. So now we can restart and we can find our minor axis. So our minor axis length is going to go from up here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So my major axis is 10. That's going to tell me that B equals 5. Now our major axis is in the x direction, so that means my A value is going to match up with x, therefore meaning my B value will match up with y. So now that I know what my A and my B values are, what I can do is go from my vertex here, and I can move 7 over to find that center. 1, 2, 3, 4, 5, 6, 7. So this ordered pair is my center. So what I have to do is I have to find the origin. Be really careful because the origin kind of moves around on these graphs. So my center is 1, 2, 3 to the right, 1, 2, 3, 4, 5, 6. So my center point is at 3, 6. My A value we said is 7. My B value is 5. We know where A goes is lining up with my x, so we can plug this into our equation now. Remember what your equation is. X minus h squared plus y minus k squared equals 1. We got to figure out where to put the A and the B. We already decided A went with x squared, so we'll put A squared and B squared. Now we can start plugging everything in. So x minus 3 squared plus y minus 6 squared equals 1. That 3 and 6 is coming from my center. And now my A value we said is 7. So we'll have 7 squared, and my B value is 5. So we'll have 5 squared. Clean it up a little bit. You're going to leave the x minus 3, but you're going to want to make sure you square the 7. You'll leave the y minus 6, but you'll square the 5. So my final answer is going to look like x minus 3 squared over 49 plus y minus 6 squared over 25 equals 1. And that is our final answer.